Alright, good day everyone. Before I start this video, allow me first to introduce myself. I am Marcus S. Cubalio from BSED Matri A, and today I'm going to discuss my own and unique geometric model to fulfill my requirement in my subject, which is abstract algebra. So my geometric model is inspired with spiderweb, as what you can see in this slide. So before we discuss my geometric model, so let us first define what is spiderweb. According to Merriam-Webster, a network of silken threads spun by most spiders, and it is used as a resting place and as a trap for a small prey. It is meant what is spider web. So now I name my geometric model as Markov spider web. So as what you can see in the slide, this is my geometric model. It is combination of a web, and in the center, it has a spider. The next one, in the front of my geometric model, it is color gray, and I use letters in the front. And in the back, it is color black. And in the back, I use numbers. So now, a while ago, I said that in the front, I use letters. So in each edges, I assign letters, which are M, A, R, D, O, S, Q, E. So the letters are Marcos, QT. So in the back of my geometric model, I use numbers, which are 1, 2, 3, 4, 5, 6, 7, and 8. So this is in the front, and it is on the back of my geometric model, which is Marcos spider web. So now, let us summarize the letters and the numbers which I use in my geometric model. So in the front, the letters are M, A, R, C, O, S, Q, and T. In the back, the numbers are 1, 2, 3, 4, 5, 6, 7, and 8. It is related to each other, which is what you can see, M, the front, it is on the top, and in the back, 1 is on the top. So now, let us define the movements of each letters. In the front, we have M, which stands for do nothing, A for turn 1/8 counterclockwise, R for turn 2/8 counterclockwise, C for turn 3/8 counterclockwise, O turn 1/2 counterclockwise, and S turn 5/8 counterclockwise, Q turn 6/8 counterclockwise, and D is turn 7/8 counterclockwise. So for the back of the geometric model, there's Markov spider web. The movements are, for number 1, it is flip from vertical axis. 2 for flip between vertical axis and left diagonal. 3 for flip from left diagonal. 4 for flip between horizontal axis and left diagonal. 5 for flip from horizontal axis. 6 for flip between horizontal axis and right diagonal. And 7 flip from right diagonal. And lastly, for number 8, it is flipped between vertical axis and right diagonal. So this is the summary of the movements per letters and per numbers. To further understand those movements, let us explain the rotational and reflective line of symmetries in my geometric model, which is Marcos spiderweb. In letter M, we have do nothing, which means when we operate M star M, based on our video here, there is no movement, which is M star M is equal to M, which is do nothing. Arrow in the video represent the resulting operation when we operate the first letters, the first element, and the second element. So in the table, M star M, which is here, is equal to M. Next one, E stands for turn 1/8 counterclockwise. So here, our spider web, we will turn 1/8 counterclockwise our model, which is M is the initial point or in the initial position, and A is defined as turn 1/8 counterclockwise. So this is the video to further understand the movement turning 1/8 counterclockwise. So M is our initial position, and we turn 1/8 counterclockwise. So our resulting elements is A. So M star A is equal to A. So in our table, M star A is equal to A. So next one, let's have letter R. Letter R defines turn to 8 counterclockwise. So here is our Marcos spiderweb model. So we will turn twice the geometric model as stated in the diagram. So here, our initial point is M, and we operate it on R, which is defines turn to 8 counterclockwise. So let's see. So M, our initial points, and we turn to 8 counterclockwise. So the resulting elements is R. And in our table, M star R is equal to R. And for our letter C, it is defined as turn 8 counterclockwise. So again, this is our model, and we will turn the model 8 counterclockwise as stated in the diagram. So again, our initial point is M. So when we turn the model as M is the initial position on our video. So when we turn 8 counterclockwise, the answer is the element C. So M star C is equal to C. And in the table, M star C is equal to C as shown in our table. So for our letter O, it's defined as turn 1/2 counterclockwise. So here, we will turn our model 1/2 counterclockwise. If M is our initial position, and we will turn 1/2 counterclockwise, so letter O, will be on the top, which means it is the resulting output when we operate M star O. So M star O is equal to O. Again, in our table, M star O, which is O. And for our next letter is S. Turn 5/8 counterclockwise. So we will turn the model 5/8 counterclockwise. And if we turn it 5/8 counterclockwise, and if our initial position is element M, and when we operate it in S, which defined as turn 5/8 counterclockwise, in the video presented, when we turn 5/8 counterclockwise, the resulting element is letter S. So M star S is equal to S. So here is our table. So next one, for our letter Q, it is defined as turn 6/8 counterclockwise. So it is turn 6/8 counterclockwise. If we have M star Q, it is equal to, let's see, M, we will turn it 6/8 counterclockwise. So our resulting element is letter Q. So this is our table. So next one, letter T. It is defined as turn 7/8 counterclockwise. So this is the diagram or the model. So letter T will turn 6/8 counterclockwise. So our resulting element is letter Q, and this is our table. So for the next movement, which is letter 1, I guess. For letter 1, it is defined as flip from the vertical. So it is flip from the vertical axis. The diagram, the red broken line defined as our ver- it defines our vertical line, which is this is our vertical line. So if M star 1, M is our initial point, and when we flip the model from the vertical axis as 1 defines it, let's see the model. So M star 1, which is 1 defines flip from the vertical axis, our resulting element is 1. So this is our table. So next one, 2. It's defined as flip between vertical axis and left diagonal. So again, this is our vertical axis. And this is our left diagonal. But here, as defined, it is between the vertical axis and left diagonal. So this is the um, flipping between vertical axis and left diagonal. So if we operate M as the initial point, O2 as defined as flip between vertical axis and left diagonal, is in our video, we will flip between vertical axis and left diagonal. So our resulting element is number 2. This is our table. And for our number 3, it's defined as flip from the left diagonal. So this is the model, and the red broken line is our left diagonal. This is the line where we